In this video, you will deploy a minimalistic instance of MySQL alongside a Prometheus exporter, which will extract metrics from MySQL. Then we're going to configure Prometheus to grab these metrics and save them in its time series database so that we can finally access these metrics from Grafana and visualize them in a Grafana dashboard. This video is composed of 5 chapters, and before we dive into any of them, I need to list the prerequisites needed to continue with this video. Number 1, you should have Helm installed and set up on your machine. If not, please check out this article, or this one, wherever I need to point to, and then come back. Link is inside the video description. Number 2, you should have Prometheus and Grafana installed in your Kubernetes cluster. If not, please check out this video, or this one, wherever I need to point to, and then come back. Link for that is inside the description as well. And that's all. We can start with chapter 1. All right, let's party. So I already have all of the resources that we're going to need for this lesson set up inside of a repo called MySQL Prometheus sample. I left you a link to this repo inside of your video description, so make sure that you go to it, grab the link that we need to clone this repository in some directory within our computer. I'm going to clone it directly into my desktop directory where it will be very easy to access. So I'm going to git clone it there. Let me increase the size so that you can see. Alrighty. And now, you can't really see it because I have a few screens. So let me drag it. And I'm going to launch this inside of VS Code. Use whatever editor you want. Doesn't really matter. And I'm going to create a new terminal window. Now, if you searched for this video, then you probably already have MySQL set up in Kubernetes. In this case, no need to do this step. If you were following along in the Prometheus playlist, then we're just going to deploy a very minimalistic instance of MySQL. We're not going to deploy anything crazy just because the focus is on setting up a MySQL exporter to monitor a MySQL database, so it doesn't need to be anything crazy. Normally, I'd recommend using a Helm chart or an operator to deploy enterprise software like MySQL, MongoDB, etc. But in this case, we're happy just deploying a simple secret, service, and stateful set to have a minimalistic setup. All of these are going to be deployed inside of a namespace called database monitoring, so we need to start by creating that namespace. kubectl create namespace database monitoring. All right, so here we have the namespace created. Now we're going to kubectl apply -f, all of the resources inside of the MySQL folder. And that's pretty much it. We have a stateful set where all our MySQL data is going to be persisted in a persistent volume. We have a service that can be used to access the MySQL pod. We have a secret that will be used to authenticate against MySQL and be able to make queries to it, make API calls to it, etc. So if we say kubectl get pods -n database monitoring, we should see a MySQL pod. Now, alongside this MySQL instance, I want to deploy a MySQL exporter that will consistently make API calls to it and try to extract metrics out of it, okay? That's what a Prometheus exporter is for. Prometheus exporters, whether they're for MongoDB, PostgreSQL, Redis, which I will make videos about in this playlist, what they do is they consistently make API calls to a target database and try to extract Prometheus metrics out of it and expose them at a particular endpoint. All right, just give me 1 second to drink some water. We can look at the Prometheus community Helm repository that contains all of these Helm charts. Okay, so what I want you to do is go to the video description and grab this link. Once you grab it, we need to add this Helm repository into our local Helm configuration. So I can go ahead here and I'm going to say Helm repo add. You can give the repository an alias within your local Helm configuration. I'm just going to call it Prometheus Community. You can call it your dog's name, your cat's name, doesn't really matter. But this is more intuitive. I already had the repository, so it gives me this error, in which case, just to make sure, I'm going to go ahead and update the repo. Helm repo update, Prometheus Community. All right, and now we need to make sure that the Prometheus community Helm repository contains the MySQL Helm chart. We can do that by searching the Prometheus community repository, Helm repo search. We can use this alias to search the repository we just downloaded. Oh, I'm such a doofus. The actual command is Helm search repo. I always confuse this. All right. And here you'll see that the Prometheus community allows us to deploy many types of exporters using Helm. The one we're interested in this video is, it's in alphabetical order, Prometheus MySQL Exporter, okay? Before we go ahead and install this exporter, we need to configure the values that will steer that installation. So if you took my Kubernetes course, which I highly recommend you do if you haven't, link is in the description. If you took my Kubernetes course, you'll know that a Helm chart simplifies the deployment of very complicated software, whether that's MySQL, whether that's Redis, Mongo, etc. Because what it does is it combines, it packages up all of the Kubernetes objects and manifests inside of a templates folder, abstracts it away from you so that you don't have to deal with it, and it gives you access to a values file whose values you can configure to steer the deployment towards one that suits your purposes. So really, whenever you're using Helm to install a software, it comes down to being a puzzle, a very fun puzzle where you just got to look at what the default values are and knowing which ones you need to change. So before we even think about installing this Helm chart, what we need to do is look at what all the default values are and adjust them accordingly. So what we can do is go over to GitHub, where we can see the source code for all the Helm charts, okay? I'll leave you this link inside the video description. Go to the Prometheus community charts. We'll scroll until we see the Helm chart for the MySQL exporter. All right. Inside the templates folder, we have a bunch of different Kubernetes objects that we don't have to worry about ourselves. The only thing that we need to modify is the default values inside of the values.yaml file. All right. The image, obviously, we don't need to touch. The service provides access to our MySQL exporter at a particular port. That's fine. Service monitor is something we're going to have to modify because you'll remember if you were following along with this playlist that a service monitor is what configures Prometheus to discover your metrics endpoint. All right, so right there, this tells us that the templates folder contains a service monitor object, and we can use these values to steer the logic for that service monitor's deployment. So here we can control whether or not that service monitor is enabled, which namespace it's deployed in, etc. And if we keep scrolling down, this is really interesting to me. All right, this is the first thing you should ever modify when changing one of these Helm charts, and that is the connection parameters. So the host is what's going to allow our exporter to find our instance of MySQL. And once we configure the host, we need to tell the exporter which port our MySQL instance is serving requests on. This seems to already be correct, but we're going to override it within our own values file anyway. The user is what the exporter is the username the exporter is going to use to authenticate against our MySQL instance. And then here, it allows us to extract a password from a secret that MySQL exporter can use alongside the username to fully authenticate against MySQL and therefore be able to connect to it. All right. Before I modify the user and the password, I'm just going to start by trying to connect to MySQL using the MySQL exporter. So let me go and copy these values so that I don't forget them, because we know these we have to modify into our MySQL exporter values.yaml. All right, number one, if you want your exporter to monitor a specific database, you can include that database name here. I'm going to omit that. What is the host going to be? Well, we know MySQL is deployed inside of database monitoring. So I'm going to get the service by which the MySQL instance can be accessed. Excuse me. kubectl get service -n database monitoring. All right, here is the service name, MySQL. And you'll know if you took my Kubernetes course that we should be able to access this service by first specifying the host, which is the service name, followed by the port at which the service can be accessed. And that's pretty much it. So we can start by specifying the service name, MySQL. That's going to allow it to find the host that lives inside of the same namespace, because we're going to be installing the Helm chart in the same namespace. Additional config we don't need to touch. This I will modify later. This I will modify later as well. Port 3306. All right. Now, if our exporter is deployed inside of the same namespace as the MySQL instance itself, it should successfully be able to use this host and port to reach it, if you will. But if it lives in a different namespace, which it very well might depending on your setup, then what you need to also do is specify the namespace where the MySQL service is in. So that namespace is database monitoring. All right. Followed by the Kubernetes suffix service.cluster.local. This would also work if you're using OpenShift or something. All right. And so this is ideal because this will allow our exporter to connect to our MySQL instance, whether it's in the same namespace or a different one, unless you have some sort of network policy in place. So now what we can do is say kubectl, we can install a MySQL exporter. So this is what we're going to name the Helm release, which will be based on the Helm chart Prometheus community. If I remember correctly, the Helm chart was called Prometheus MySQL Exporter. All right, -- namespace, database monitoring. So here I am going to indeed deploy it inside the same namespace as our MySQL service. And if we just deploy it like that, it's going to use the default values. We don't want it to do that. We want it to override some of these values with the custom ones we have here. So the values are inside of a MySQL exporter folder /MySQL exporter values.yaml. Unknown command. Oh my god, I'm such a doofus. This should be Helm install, not kubectl install. Sorry, guys. Going all the way back. I always hate doing this. All right, beautiful. Now, as promised, let me clear the output. If I say kubectl get pods -n, what was the namespace? Database monitoring. Now we see two pods, both of them running. Beautiful. A MySQL instance and a MySQL exporter that's constantly extracting metrics out of this instance. How can we make sure that this actually has metrics? Newsflash, it won't. And we can verify that by going to the endpoint where this exporter is going to expose all of the metrics that it scrapes from the MySQL instance. So I'm going to say kubectl get service -n database monitoring. All right. The service is going to expose all of the metrics that it manages to extract at the port 9104. So what I can do is do a port forward to see if there are any metrics. Service /MySQL Exporter. Let me just copy it. So remember what I said, that this is all just a big puzzle. You deploy one thing, you see what's wrong, you troubleshoot, you go back, adjust more values until you get a deployment that works. All right, -n database monitoring. And I'm going to follow this with an ampersand so that it also runs in the background. All right. So now if I go and say localhost 9104, here I see the home page for the MySQL exporter. Okay. But I want to look at the metrics that it's exposing, which usually most exporters expose at a metrics endpoint. All right. And all I see is a bunch of Go related metrics, which makes sense because of the Prometheus exporter's Go environment around which it was developed. But we don't see any metrics relating to the MySQL instance that it's supposedly pulling metrics from. Why is that, you might ask? Well, this is where we debug. So now this is still running in the background. So what I can do is kill the port forward. And what this is going to do is kill the first process running in the background for this terminal session. All right, got killed. Let me clear the output. I'm going to say kubectl get pods again, -n database monitoring. All right, and now what I can do is play with some logs. So kubectl logs, we want to stream the logs for the following pod to see what the heck is going wrong. Oh, got to specify the namespace. So again, whenever you don't get the results that you want, look at the logs or describe the pod or whatever, but don't panic, just troubleshoot. And now we just simply need to scroll through it. So here we see, it's literally the first thing we see. Level error source is equal to exporter error opening connection to database. So it found the database. It was able to find it. So now we know, come on. Why did I do this? Sorry guys, give me a second, I'm struggling. So now we know that the host allowed the exporter to find the MySQL instance, and it's able to access it at the port where it's allegedly serving requests, but it's being denied access. Why? It needs to authenticate. Okay, so right there, I know exactly why the exporter isn't able to grab any metrics. How can it authenticate? A username and a password. Now, you normally never want to specify a password in plain text. So what we're going to do, the user is fine. We can specify that in plain text. What is the username that the exporter is going to use? Again, so the secret specifies all of the credentials needed to authenticate against MySQL. This is the MySQL secret. Let's make sure that secret is deployed. kubectl get secret -n database monitoring. All right. And the MySQL user that can be used to authenticate against it, this is base64 encoded, but it's actually MySQL user, so we can modify that. And I just told you the password you never want to actually specify in plain text. Now you need to see if this exporter allows you to configure a value which can somehow leverage the password stored inside of the MySQL secret. If not, we have no choice but to use the password field. But ideally, I want to avoid that. So let's go back to the connection parameters. All right. Oh, there it is. Existing password secret. Pretending like I didn't search it up before this lesson, but yeah. Anyways, it does have it does have a value that we can modify to grab the name of the secret that is deployed, and once it gets the secret, what the key for the secret password is. All right, so we can go ahead and play with this. So what is the name of the secret? Well, I just got the secret, and it's MySQL secret. What is the key that is referring to the password that we need to authenticate? MySQL password. All right. So what it's going to do is it's going to grab the password value, and now alongside the MySQL user, it will use this information to authenticate against MySQL. Simple as that. Will this work? Did we solve one piece of the puzzle? Let's find out. So we can go ahead and upgrade the Helm release that we currently have with the new values. So Helm, upgrade. We can upgrade the existing MySQL Exporter release. Specify the Helm chart again, Prometheus MySQL Exporter. All right. We can upgrade the Helm release that was deployed in the namespace database monitoring with the new values inside of MySQL Exporter / MySQL Exporter values.yaml. Alrighty. Let me get a drink of water real quick. What to do now? So now we want to make sure. Let me clear the output. kubectl get pods -n database monitoring. Now we want to make sure that this is actually able to authenticate against MySQL and ideally be able to grab metrics from it. So kubectl logs-f for the following pod -n database monitoring. I don't see an error. Do you? I'm pretty optimistic. All right. I shouldn't have killed the earlier port forward. Let's clear the output. kubectl port forward. I do not remember the service name. kubectl get service -n database monitoring. kubectl port forward service / what am I doing? All right. Port forward, port 9104 to local machine port 9104 -n database monitoring. We'll run it in the background as well. Localhost 9104 / metrics. So notice now it's just a bunch of Go metric data that's specific to the exporter itself. Will we now have metrics for the MySQL instance? There you go. A whole bunch of metrics. I'm just going to kill what we have currently. Or you know what? Let's not kill it. Yeah, let's kill it. I'm going to kill it because I'm also recording and I only have a MacBook Air M1 and it's already starting to slow down. You can feel free to keep it. So now, the MySQL exporter is exposing all of this metric data at this endpoint. So now what we need to do is deploy a service monitor that tells Prometheus, hey, there are metrics being exposed at this endpoint. Can you please scrape them? And what we can do is, number one, deploy our own service monitor, which is very easy. Or number two, check if the exporter has a service monitor within its templates folder whose values we can configure towards a deployment that suits us. So it does have a service monitor.yaml. So what we can do is play around with the values inside of values.yaml in order to configure the service monitor for our purposes. So by default, the service monitor is not enabled. So what we need to do is enable it. I'm going to start by copying what we have inside of MySQL Exporter values. Okay. And what do I need to fix? Enabled, true. All right. Additional labels. So this will depend on whether or not you installed Prometheus using the Kubernetes stack. If you did install it using the Kubernetes stack, then your service monitor, in order for it to be discovered, it needs to have the label release Prometheus. Because that's just how Prometheus is configured when deployed using the Kubernetes stack. It will only discover service monitors that have this label, so we give it that additional label. Okay. Job label, whatever, no need for that. Multiple target, no need for that. I feel like I might have deleted too much. So by default, the service monitor is going to have an interval of 30 seconds, a scrape timeout of 10. It will be deployed in the namespace monitoring, which is where my Prometheus instance is. I'm going to allow it to run there. It doesn't matter. All right, and that's all I really want to do. Okay. So now we can say kubectl, not kubectl, I keep making that mistake, Helm upgrade. I have the command somewhere. So now that also deploys a service monitor that's going to configure Prometheus to scrape the metrics exposed by this exporter every 30 seconds. And this allows the service monitor to be discovered by Prometheus. The service monitor is going to be deployed inside of the namespace monitoring by default, but that's fine. It doesn't have to be in the same namespace. I'm guessing that's it. It doesn't have to be in the same namespace as your exporter, because a lot of people make the mistake of thinking that it's the service monitor that's pulling metric data from the exporter. No, that's not what happens. The exporter is exposing all of this metric data, and the service monitor, all it does is it configures Prometheus to find the metric data exposed at this endpoint. So the service monitor is interacting with Prometheus, not directly with the exporter. It's Prometheus that pulls all of this data, okay? And how can we make sure this data is now in the Prometheus database? Well, since we also have Grafana connected to the Prometheus data source, by deploying this Grafana dashboard, if we see data, then effectively the data is inside Prometheus and we should be able to monitor it using a Grafana dashboard. Okay, so that's going to be our final step. I'm going to say kubectl. Let me clear the output. Kubectl apply -f Grafana. Apply this dashboard inside of the monitoring namespace, because inside of the monitoring namespace I also have Grafana there as well. And what that's going to do is create a config map with the Grafana dashboard with the label 1. Grafana, when deployed using the Kubernetes stack, will automatically detect the dashboard with this label and import it. Okay, so now what I can do, first of all, I just want to prove to you that I do have Grafana deployed in that namespace. Get pods-n monitoring. Yeah, damn it. kubectl. All right, here I've got Grafana. Let me get the Grafana service, kubectl get service -n monitoring. All right, the service I want to port forward is the following. So let me copy this, clear the output, kubectl port forward, service Prometheus Grafana. We want to port forward it on our local machine port 3000. The cluster IP port, I believe, was 80. -n monitoring. Let's run this in the background. Why not? So now we'll go ahead and say localhost 3000. Go to Grafana. And by virtue of following this tutorial, you also get a pretty cool, that's Postgres, that's for another lesson. Pretend like you didn't see that. MongoDB, where's the MySQL dashboard? All right, fast forward 5 minutes. There was an issue with the Grafana dashboard. This said Postgres, where it should initially be MySQL. I also had to delete a bunch of other conflicting dashboards that I had prepared for other lessons. But anyways, if you were watching this video, you should have been fine. If you see a bunch of metrics for MySQL, congratulations, you conquered the Prometheus exporter for MySQL. If you want to, feel free to look at all of the other values, see how they would suit your purposes. You're welcome to, but not only do you now know how to configure MySQL exporters to scrape MySQL instances and save that data to Prometheus, you also get a Grafana dashboard for free. All right, that's pretty much all I want to teach you for this lesson. If you go ahead and populate your MySQL instance with some dummy data, you should see some much cooler metrics that you can visualize. And I'm going to leave it at that. In the next lesson, I'm probably going to show you how to deploy the exporter for either Postgres, Mongo, or Redis. So I'll see you in the next one.